Okay, guys, so let's finish this off. What we have to do is the ear, and that's pretty much it for this whole chapter in the semester. So the ear, let's keep it pretty simple. We want to go through spat, miss, ocha. It's a mnemonic to help you remember the outer ear, middle ear, and the inner ear components or structures. So sound passes through what we call the pinna. So I just remember this as hearing a pin drop. So the pinna is also known as the auricle. Sound then transmits through this. This is called the auditory meatus. Be careful, it's not the auditory tube. This is the auditory tube. This is the auditory meatus. So once it ends at the meatus, it hits the eardrum, also known as the tympanic membrane, and then it transmits sound into these three little ossicles here. And the ossicles are tiny little bones in the ear that allow transmission of sound, and they are the malleus, the incus, and the stapes. The malleus, I just remind myself, it looks like a mallet. The incus is, another word is anvil, it means anvil, and then finally the stirrups on a horse that you put your feet into are called stapes. They sit on and actually push into this thing called the cochlea through the oval window. And then it affects the cochlea, which is associated with sound transmission. Finally ends on what we call hair receptors or hair cells, and it follows through the nerve called the auditory nerve, also known as vestibulocochlear and cranial nerve 8. So one more time. Spat, miss, ocha. External ear is sound, transmits through the pinna and travels through the auditory meatus to end up on the tympanic membrane. The middle ear is the malleus, incus, stapes, which are also known as ossicles, and the inner ear is the oval window, transmits sound into the cochlea, which hair cells receive the information and then send it through the auditory nerve, also known as vestibulocochlear, cranial nerve number 8. Some of you might know this, kids versus adults. This is called the Eustachian Tube, also known as the auditory tube, and it connects between the throat and the nose and then the ear. So in kids, this is a little bit flatter. In adults, it actually elongates and becomes a little more angled. So when you're a child, the infection can spread up easier into the middle ear. That's why they have more infections in the ear versus the adult, which doesn't have as many infections. But you notice when you go on the airplane and there's a difference between pressure on the outside here and pressure on the inside, you start to feel the buildup of pressure. So how do you alleviate that? You actually have to maybe chew gum or adjust your jaw to open up the Eustachian tube so that you can allow a balance and equilibrium between the pressure inside of the middle ear and the pressure basically in the atmosphere through the nose. So let's keep going. These are the structures you guys want to know. The auricle, also known as the pinna, it's a part of the external ear. Spat, miss, ocha. What are the three auditory ossicles? Malleus, incus, and stapes. And then what is the eardrum? Tympanic membrane. And then what does these three bones, what do they actually push on in order to transmit sound? It's called the oval window. There's something called the round window, and if you've ever seen a closed box with fluid inside of it, if you press on the box, you can't really change anything within the container because the fluid itself is non-compressible. Like the ear, the fluid inside of here that allows us to transmit sound is non-compressible. So if I was to push here, I'd need a release valve, and the release valve is called the round window. So whenever I push in this direction with the oval window, I push outward with the round window to alleviate some of that pressure. So cerumen, I'm just going to have fun with this. You will never see this again or use this ever again. Just remember, earwax is called cerumen. Middle ear was malleus, incus, stapes. So malleus was the mallet or the hammer. Incus is the anvil. Stapes is the stirrup. Auditory tube communicates between the nose and throat and the middle ear. So this is where infections occur. And then again, malleus, incus, stapes were three of the ear bones, and they transmit sound. So what happens is sound or air waves travel through the ear. They hit the drum, and then they push on the bones, which then push into the fluid to transmit your sound. If I'm at a concert and Let's say that it's really loud, so you're yelling at your friends. You're like, oh my goodness, this is so fun, yay! All right, after you finish your concert, you guys go to uh, Zippy's, or you go to someplace that you guys want to eat. And what happens? You start to yell at your friend. Why are you yelling at your friend? Well, you have adapted to that loud sound, and your body still hasn't come down from it. So you're yelling at them because there's two muscles that will help to protect your ear and protect it from being damaged. The tensor tympani actually holds on to here, right, to prevent the tympanic membrane from transmitting sound. It's almost like if I was somewhat of an annoying child, I used to hit the drum a lot, right? Or you press the button that makes the sound over and over and over again for like hours. And so imagine yourself hitting a drum and then somebody being so annoyed that they slap the drum and they hold it down with their hand. The tensor tympani is like a hand that slaps and prevents the resonance from occurring in the drum itself. Well, what else can I do? Remember, sound is transmitted from here across the ossicles and into the cochlea, which receives information for sound. Now, another way that I can prevent the sound from being sent is holding on to basically the foot, right? The stirrups that would affect the oval window. So two muscles that reduce sound are tensor tympani, which attaches here to the tympanic membrane essentially, and stapedius, which attaches to the stapes to prevent the stapes from transmitting the sound. Here we go. This is another image. So this is the tympanic membrane, the malleus, the incus, and then the stapes, right? I mean, not this one, but the malleus, the incus, and then the stapes, right? Which looks like a stirrup that pushes into the round window to send sound information. Tensor tympani and stapedius reduce the transmission of sound. Internal ear is basically, in general, for hearing, it's the cochlea, but remember that the ear, cranial nerve 8, vestibulocochlear nerve, has two parts to it. It has one for balance and equilibrium, and then it also has another part for hearing. Balance and equilibrium are these two things. So the vestibule, I'm not going to ask you about this, but I am going to ask you about two of the parts. When we come across it, they're called the utricle and saccule. The US, the United States, is always linear in progress. They always want to keep going in a straight line to get to their goal, right? But how I remember what the utricle and saccule does or do is that, like the US, they're linear in motion, so they're associated with linear acceleration. If I'm driving in a car and I speed up, that's linear acceleration. If I slow down, that's also linear acceleration. But what if I spin on a chair? Well, I have other means to detect changes in equilibrium by looking at what we call semicircular canals. So one more time, utricle and saccule are linear acceleration, semicircular canals are angular acceleration. And then what is the cochlea? That's for hearing. So here we go again. If it's circular, it's going to deal with angular acceleration. If it is just a straight line, that, like the utricle and the saccule, it's going to only deal with linear acceleration. And this guy that looks like a snail shell, what is he? He's the cochlea. What does he deal with? He deals with sound transmission. And this, the combination of the two, is cranial nerve 8, vestibulocochlear, also known as auditory nerve. Within the labyrinth, if you look at this, you see the blue and then you see like the yellow around it. Well, this structure is almost like a little container. And the important structure that I want you guys to know is found inside of this circle. It's the organ of Corti, and when we get to it, I'll repeat it again. But this fluid on the outside versus the fluid on the inside, it's almost like a cell. Remember I said couple of lectures ago, I said you throw a banana in the ocean, the banana has high potassium, and the ocean is made up of sodium and chloride. So the same is true for the ear. This fluid inside here called endolymph is made up of potassium. This thing that wraps around, perilymph, is made up of sodium and chloride. So the ear is different. Most cells, like nerve cells, are triggered or turned on by the movement of sodium into the cell. In the case of the ear, the sound wave and transmission of sound is signaled by the movement of potassium outward from here moving outward across. There's a membrane that it moves across.